Welcome back, everybody. We're going to be talking about 2-5 notes today. So, much like the difference of two squares, there's also a difference of two cubes. We're going to be talking about the difference of two cubes today and the difference, or in the sum of two cubes. To begin with, let's review difference of two squares. Difference of two squares stated simply that a squared minus b squared is equal to a minus b multiplied by a plus b. All right, so for example, if we had 4x squared minus 16, then that would be equal to 2x minus 4 multiplied by 2x plus 4. Very simple, very easy. Much like the difference of two squares, if you come across the difference of two cubes, there is a shortcut for factoring that as well. Difference of two cubes states that a cubed minus b cubed is equal to a minus b multiplied by a squared plus ab plus b squared. Unlike the difference of two squares, there is a sum of two cubes. The sum of two cubes says that a cubed plus b cubed is equal to a plus b multiplied by a squared minus ab plus b squared. So let's look at example number 1. Example 1, we've got it asks us to factor 27x cubed minus 64. Here, much like the difference of two squares, we can write this as the sum, or the difference of two cubes, meaning that we can say that the cubed root of 27 is 3, and the cubed root of x cubed is x, all of that cubed, minus 64, the cubed root of 64 is 4. Which means that a is equal to 3x, b is equal to 4, and we can throw that into our equation. We've got 3x minus 4 multiplied by 3x squared. What I mean by 3x squared is 3x times 3x, and 3x squared would be 9x squared. Plus a times b. A times b is 3x times 4. 3x times 4 is 12x. And then b squared is 4 times 4, which would be 16. That's our answer. Example 2, very similar. The only difference is we have a plus sign, so which means we're going to need to use the sum of two cubes equation. Here, we can rewrite this the same way. We end up with 3x, all of that cubed, plus 4 cubed, where a is equal to 3x and b is equal to 4, which means that our final answer here is going to be 3x plus 4 multiplied by 9x squared minus 12x plus 16. The only difference is we're using the sum of two cubes formula instead of the difference of two cubes. Now, if you notice here in the two equations, they're very similar. They both have the exact same components. Notice that all the letters are the same. A, B, a squared, AB, AB, b squared, and b squared. And the difference lies where we see the signs. The signs are changing throughout the problem. So the difficult part in actually memorizing these two formulas is that we need to figure out in what order these signs exist. Keep in mind that it is going to be a requirement that you understand that in the first parenthesis we've got a and b, and in the second parenthesis we've got a squared, ab, and b squared. If you can remember that order of those, then all you need to do is remember the order of the signs. At the bottom of the notes, I've put this little piece here, this mnemonic device. You don't need to remember a song. You don't need to remember anything crazy. All you need to remember is what you bathe with every night, soap. So same, opposite, always positive. And what that means is, if we go back to the difference of two cubes and the sum of two cubes, is that we've got a minus sign in the difference of two cubes. So we've got the same sign, the opposite sign, and then always positive. Same, opposite, always positive. Likewise, in the sum of two cubes, we've got a plus sign there. So in our formula, we're going to have the same sign, the opposite sign, and then always positive. That's going to give us all the correct signs we need in order to get all of these problems correct. All right. Thanks again.